Eurographics 2018 conference here in Delft. I have the great pleasure to introduce to you Jarke van Wijk, who is a full professor at the Department of Mathematics and Computer Science at Eindhoven University. Let me tell you a little bit of the background. He received his Master of Science in Industrial Design Engineering and his PhD degree here from Delft University of Technology in 1986. Afterwards, he worked 10 years for the Netherlands Energy Research Foundation, ECN, and he joined Eindhoven University of Technology in 1998, where he became a full professor of visualization. His PhD was actually done here under the supervision of Erik Janssen, who was leading the computer graphics and visualization group before. His main research interest is stemming back from his time on information visualization and visual analytics, with a focus of the development of new methods for the interactive exploration of large data sets. And this is now also continued in the form of the directorship of the Data Science Center in Eindhoven. The work of this group has led to many startup companies, including Magnaview and Synapsco. He has co-authored more than 150 papers in visualization and computer graphics conferences and received 6 Best Paper Awards. And I also want to point out at this point, because it is really a striking, I think, uniqueness, he published also 3 SIGGRAPH papers as the sole author on the papers. Additionally to this, he received the IEEE Visualization Technical Achievement Award in 2007 and the Eurographics 2013 Outstanding Technical Contributions Award. I'm really looking forward to his talk that will show you some of the brilliance of his work, and I'm really impressed always by the striking curiosity that's driving his research and also the entertaining content he gives. In particular, he's going to start with one image, and I want to tell a quick story about this, because when I arrived here in Delft, I got this present of the first raster image that was generated at TU Delft, and it was done by Jarke van Wijk under the supervision of Erik Janssen. I'm very much looking forward to more stories from the past and to how we can overcome the challenges for visual analytics.
Many thanks, Elmer. Many thanks for inviting me to come over. You set the bar quite high. I hope to tell something interesting. For several reasons, I'm very happy to be here. Of course, it's a big honor to be speaker at the main conference on graphics in Europe. But also, this feels like coming home a bit, as Elmar already pointed out. I started here in Eindhoven in '77 as a student in industrial design engineering. And then in '82, I started as a PhD student in computer graphics, supervised by Erik Janssen in Bronsford and Professor McConnell. This was one of my first results. This was my submission for the art competition of Eurographics in Zagreb in '83, and it won prize for the best submission. Well, there were only 3 of them, so... There's sometimes some moments I think I'm getting old. I have attended Eurographics in a country that doesn't exist anymore, Yugoslavia. I finished my PhD in '86 on ray tracing, geometric modeling, and then I went on, and coming hour I'll tell you something about what I've done since '86. I want to talk about information visualization, give you an update on how we think in our fields, about visual analytics, and finally I'll come to a topic that really is very fascinating and interesting, and that's how to understand models. All the examples I'll show, almost all will come from Eindhoven. That's not because no excellent work is done outside Eindhoven. It's simply because I know that work best and can tell you some stories about it. People think big data is focused about data. That's wrong. Big data is about people. Yeah? Because in the end of the day, it's people that produce and collect all this data. Also, it's people that want to get insights from the data. How to get this insights? We from the visualization community have a simple answer. Let's make a picture and it will give you a lot of insight. We lean on the power of our human visual system, and as many of you probably know, the eye is just a small part of it. Much more important is that a large part of your brain is dedicated to processing all this visual information. In an overview talk on visualization, this example should not be missed. I think I never have seen a keynote without Enscom supported. It's a true great example of the power of visualization. This is from the 70s. Enscom was a statistician, and at that time they were pushing the idea of exploratory data analysis. Here you see 4 data sets. Each data set is very simple, consisting of pairs of values, x and y. And one obvious question is, are those data sets the same? Could they be samples from the same population? If you're a statistician, you start to calculate things like averages, variances, correlation, you apply linear regression, and in all cases it seems that all those 4 data sets are exactly the same. Well, I'll give you 10 minutes to check if you also think this. You can look at it forever, but okay. But now let's have a look at a picture, and then the picture becomes immediately very different. Yeah? On the top left you see something that you sort of expected, some noise, but there's some nice correlation. There on the top right you see that linear approximation probably not a good idea. Looks more like it's a quadratic pattern. The bottom left you see that one outlier can mess up a lot of your statistics, and the one on the bottom right is even more weird. You see that the x values are all the same, and there's just one outlier that messes up all the statistics, leading to wrong conclusions. So, making a picture is a good idea. There are some issues though, or rather I should say challenges. In the real world, data is big, and also data is messy, and that's sort of the key problem we try to address. There are quite some standard ways to visualize standard data. If you have tables, scatter plots do a great job, histograms. If you have a hierarchy, show a tree diagram. If you have a network, link diagrams work out wonderful. The problem, however, is that if you start to apply them to bigger data sets, you suffer from a lot of clutter. Things start to overlap, and especially networks turn into what we experts in visualization call hairballs. Yeah? I heard stories that some of my colleagues have a lot of success by producing and showing these hairballs. Customers love it because they can tell the message to the people they cooperate with, look, I'm doing incredibly complex things and I'm a genius that I can understand those hairballs. But if you really want to extract insight, yeah, you should maybe do something else. When I started in Eindhoven in the late 90s, I'd done scientific visualization, mainly flow visualization, and I thought it's a good idea to start something new. So I went into the world of information visualization. This first example I produced, this shows a visualization of the contents of a hard disk using a technique called cushion tree maps. The encoding is fairly straightforward. Each rectangle represents a file. The bigger the rectangle, the bigger the file. The color tells you something about the type of file. And also the hierarchy is reflected by the layout and also by the shading and the geometry. You see some big columns there that are folders at a high level, and you also see strips. Well, this is a recursive process called slice and dice, and it gives you this kind of patterns. Here you also see my graphics plot. I thought, okay, those infosys people are just making very dull, boring diagrams. Let's put in some knowledge from the world of graphics. Let's put in some geometry, some shading. And then we can emphasize the hierarchical structure much better. We published on this, we made the little tools that we made available. We got many reactions. People replied that they were happy with the tool because it really saves them from buying a new hard disk. Other people said, well, images look very cool, but I don't have any clue what they mean. Also nice. If you think this is somewhat weird, you can make it much stranger. This was the next attempt on visualizing hard disk, our botanically inspired tree visualization. The visual encoding is fairly straightforward. Each branch is a folder. This is the root, right? Each sub-branch is a subfolder. Yeah? And the key insight of our student at that time was that you shouldn't use leaves as a metaphor. That gives a big mess. It's a much better idea to use fruit. Yeah? Those fruity objects represent collections of files, all in the same folder. Each cone represents one single file. The bigger the cone, the bigger the file. And the color tells you something about the type of the file again. That produces really wonderful imagery. We were lucky here that we could lean on a big tradition in visualization of botanic structures. Really very elegant, simple algorithms that are very efficient and powerful. We leaned on the work of Oliver Deussen, for instance, to get the cones on the spheres. And produced highly fascinating imagery. In the real world, in many cases, maybe you can argue all cases, it's not just a table or just a hierarchy or a network. In many cases, you're confronted with some combination of all those elements. Think, for instance, when you study communication between people that work in different companies, in different countries, they communicate with each other, also some dynamic dimension. Now, how to visualize this? My PhD student Danny Holsen found a nice way to do it. Here you see a visualization. The outer ring represents the hierarchy. In this case, it's about a software system. On the lowest level, you have modules that call each other. These are represented by lines. Each line starts green, ends up red. So here in the bottom you see area that's heavily called. And what you probably also see that this is somewhat messy. Well, what do you do if things get messy? You bundle them together. That's what Danny did, and it led to the hierarchical edge bundles. And now you get a picture that's much easier to grasp. Also, this led to a spin-off company, Cinescope, and I'll show examples of the work later on. Okay, this approach, leaning on representation, is somewhat old school. In the 90s, early 2000s, we strongly believed that, okay, just take the data, translate it into geometry, shape, color, maybe 3D, and you'll get a lot of insight. We learned that this has its limitations. The biggest problem is maybe our human perception itself. It's totally amazing what your perception can do, only evolution did not take interpretation of data into account when things started to develop. Okay, this is a classic way to visualize distributions on a pie chart. I'll give you a simple task, and please raise your hand when you're ready. Here we go. Sort them for increasing size. I see the first hands coming. Okay, so about half a minute, and most of you have figured out that the pattern actually is quite simple. A is the smallest, followed by B, C, D, and E. Half a minute. Okay, I'll show a different representation. And same challenge. Okay, this one is trivial, right? Pie chart is not. So that means that using a pie chart in many cases is a very bad idea. Yeah? We find it very hard to judge angles, to compare them, to sort them. So my take-home message of my talk is if you want to visualize data, think very deeply how you use space. If you want to perceive things, our perception is very strong in judging positions. And if you compare that to shape, color, angle, orientation, line thickness, attributes like this, well, those all fall very much behind using position. So, another example of limitations of our perception. How many disks do you see here?
Three, maybe?
Okay, let's try it again. How many?
Four.
Four, okay. Now, next one. How many red objects do we see?
Three.
Three. Wonderful. Next round. How many red disks?
Four.
Okay, that was a somewhat more mixed response. The correct answer here was 4. And I hope you felt that this case was qualitatively quite different from the previous ones. The previous ones you could catch them just by one look at them. Here it's getting harder. The problem is that I asked for 2 cues simultaneously, being red and being a disk. That's not built in our brain. Yeah? We can fulfill this task, but only in a much slower way, namely by scanning from left to right and doing a check each time, is it red, is it a disk? And because of that, the performance drops down. So, representation, it's very important to think about it, but also there are limitations, and mainstream thinking in many of the people in the InfoVis and visual analytics field are convinced now that keeping it simple is often a good idea. The next important weapon to provide more insight is interaction. It already has an important place in the standard widely accepted definition of our field by Stuart Card. I'll show a little demo. Should have tested this. Okay. This is one of the many examples of modern information visualization interfaces. There are multiple windows showing an aspect of the data. You can click on anything and selections are highlighted across the different views. You can sort things, you can filter things, and in all this, interaction plays an important role. By introducing interaction, you're getting more engaged, and also you can focus on things that you find interesting in this particular data set. Most of the work of my students these days follows this pattern, many different views. Using simple representations and leaning heavily on interaction. This is, for instance, work of Delft Corporate. Suppose that you have a large image collection, say 100,000 images, and you want to categorize them. You can show them dependent on different attributes of the data, leaning on the metadata that you get together with the pictures. You can represent them in different ways by scatter plots or like in this way by histogram. Here you can add your selection to different categories. This was work of Stefan de Elsen on interactive visualization of very large networks. The main view is this one, which is actually a sort of scatter plot. Here we chose longitude and latitude as axis. It shows the US. You can also choose other aspects. The data shown here, by the way, is migration between counties, more than 4,000 counties, and many attributes for the counties themselves, and also for the edges. If you want to show everything simultaneously, it becomes a big mess. So here we lean heavily on making selections, for instance, areas that you find interesting, but you can also make selections on the domain. Here you see a list of those selections inspired by layers of Photoshop, and important ingredient is shown here. It shows a sort of visual summary of properties of the different selections. A high-level infographic style. You can also add labels to it, showing the numbers to get more exact information. You can add little histograms and other visualizations here in boxes. And here we tried to make the bridge between explorative visualization for experts that want to get more insight and an infographic style visualization so that you can communicate your findings and show them to other people. Event data are all over the place. This is, for instance, about network protocol data from Ron Kappers. This is about MRI scanner event data, cooperation with Philips. Philips is making a lot of big medical devices. Also, they have access to all kinds of logs of what those machines are doing in practice. Here you see a big list of all the machines that they have in the field. You can select one. Here you see an overview of events, followed by the number of events with some selection opportunities for what kind of events you're interested in. You can select one day, and this shows in a fairly straightforward way what kind of events occurred. Next you can select one particular event, and here details on the event are shown. So this follows a well-known design pattern from Schneiderman. You start with a global overview, and via some steps you can go to details of individual events. Similar story showing event visualization for ASML wafer scanners. Who of you have never heard of ASML? Okay, well, ASML is a company we in Holland, and especially in Brabant, are incredibly proud of. They make the ultra high-tech machines you can think about. If you look at your cell phone, the chance is about 100% that all the chips in there are produced by a machine made by ASML. They have a market share of 80%, and well, they're leading in producing manufacturing of chips. Completely different case. This is about antibiotics resistance patterns. As you probably know, this is getting a big problem in modern society. Bacteria are getting resistant against different types of antibiotics. Cooperation with the Dutch National Institute, where a lot of lab tests are collected. They're interested in finding patterns. If people are resistant against one certain antibiotic, what are the probabilities that they're also resistant against another? Here you see an overview of many occurring systems. You can select one of those patterns, and here more detail is shown. Missing data, if you attack real-world cases, the very first thing you're confronted with is missing data. But you have to be careful with that. Here, my student used imputation to fill in missing data, but as an extra surface, he also wanted to show what his algorithm was doing. So, interaction. Well, if the data is really big, you have to make a next step, and you have to rely on the knowledge and expertise of people that have worked on reducing big data sets already for a long time. We use technology from statistics, machine learning, data mining. The challenge here is to get rid of the data. Rather than directly making a visualization, you first make a model, and you can show that to people, show some statistics, but also it helps to make a visualization of the results of the model. And also, if possible, integrate that with a visualization of the data. Well, in this talk I already showed this pattern. This is exactly what is going on. Here you show the results of a model, a linear regression line, and also you show the original data. Right? Wonderful, beautiful, works perfectly. Now this picture keeps haunting me all the time. It's a sort of metaphor of what we would like to achieve. But now suppose that you have 1 million data points with 500 attributes, and you have a deep learning network that is doing the modeling. How to show that? It's a challenge. More about that later. Interaction also plays here an important role, not only to control the visualization, but also to steer your model and maybe improve on it and see the interactive results. So in our community, we call this visual analytics. We try to get an optimal synergy between computers and humans. Computers are very good at doing stupid, simple things very fast. Humans have domain knowledge, they have common sense, and they literally can see things that are hard to compute. Here's a schematic picture of the playing fields. If you have small data sets, be happy to use just business graphics, be happy to use Excel, overall all the defaults, but for the rest, perfect tool. In InfoVis, we are typically focusing on thousands of elements, and when the data sets get bigger, you first have to remove them, before you can apply methods from information visualization or business graphics. So that's what we're trying to do. We try to make things simpler, and meanwhile we try to be careful that we don't lose essential information. Some examples. This was work I did just before starting in Eindhoven. I worked at the Netherlands Energy Research Foundation, and one of the challenges there was give people insight in energy consumption. This is a sort of classic visualization approach. Fingerprint plot. The scheme is quite simple. Here are the hours of the day as the days of the year. You see the ridges corresponding to working days. You see some seasonal variation. When I show this image to experts, the biggest shock was that there is a big grey block behind, and it means that 24/7 there's energy consumption. You would expect that it would be much more correlated to people working in office hours, but the experts explain it by telling me that there are a lot of experiments that are going on 24/7. Nice picture, but there are subtle things you cannot see here. For instance, what's the pattern over a week? Is there a difference between Mondays and Fridays? You might want to know. So I used a different approach to visualize this. This is different data. This is data about how many people are working at a certain moment in the office. Yeah? You see that roughly they start to work somewhat before 9 and about 5 o'clock they leave. The mechanism I used was very straightforward. Take 1 year of data, chop it up in day patterns, apply, in this case, hierarchical clustering to find clusters of similar patterns. Select how many clusters you want to see. And here on the right, I show typical patterns over the day. And here I show at what moment of the year they occur. So you see this pattern when there are a lot of people working, sort of the standard pattern. Here is the next pattern, the dark brown one. Happens on Friday. Part-timers probably don't work on Friday. You see it in summer. And if you combine the effects, you see the Fridays in the summer. Look at this green line, even less people are working. This blue line corresponds to day like the day after New Year's Eve, the day between Christmas and New Year's Eve. That's of course the weekend pattern, and only very few people are working. Here you see somewhere a strange outlier. On Saturday suddenly people are working. It was an open day of the institute when people showed up for work. And my favorite pattern here is the red one. And suddenly a lot of people leave office 1 hour earlier. It happens to be the 5th of December when we celebrate Santa Claus, and the boss allows us to leave office earlier. Okay, very simple presentations. I didn't have to explain you what the visual encoding was. I used proven technology, line charts, calendars. Wonderful, it works. It's often tell that my students, it's very hard to beat the trivial solutions. Yeah? So if you're not convinced that your solution is really better, just lean on those simple solutions. But by using interaction, in this case, for instance, you could click at points in the calendar and see the corresponding curve for that particular day. And statistics, here quite simple, that's straightforward clustering. You can provide a lot of insight. Now, let's go for some more big data. This was work of my student Stefan Elsen. He participated in something called the Data for Development Challenge twice. This was the first time he participated. The data challenge was brought forward by Orange Telecom, a French telecom company, which has a lot of contacts, especially in Africa. There was support from the United Nations and MIT. And as the name suggests, the idea was, okay, let's have a look at big data and see how we can use that for social, economic purposes to benefit countries. The data we used consists of 1,100 polls in Ivory Coast, and the data was provided about hourly communications between those polls for a period of 5 months. So what we got was a network with 1,100 nodes, and in principle connections everywhere, and then dynamic version. Steph worked very hard to make sense of that. I'll show you some animation. At first we thought we must have some indicator about the status of the network, and that makes it easy to pinpoint special situations. Well, we tried a lot of different things, but we're not really successful here. On the right you see a sort of fingerprint plot showing different stations and using some clustering to compare them, but also that did not really work out. Finally, we found something where we could contribute. The trick was not to look at the steady state, the current state, but rather look at variations in the signal, so that you can pick up special events. So here you see a number of day patterns visualized, and you see some strange variation, and you see some strange patterns occur. Red means here less than usual, and green means more than usual. Steph had access to a source of news messages about Ivory Coast, and together with experts from MIT, he was able to link those news messages to the patterns that his visualization showed. It includes, for instance, bad weather or local riots, local festivities that led to increases of telecom traffic. Another example, again one from Paul van der Corporate, a more recent one. Suppose that you have a big image collection, so say all Flickr images from the Netherlands. You can ask many different questions, like who are the people that made those things, what are they interested in, when did they make these pictures, where did they make the pictures. And on the next level, you can also relate those different aspects. What are typical activities of people? What kind of concepts are interesting as a function of time and space? And what are the interests of people? This is his visualization. I'll quickly talk through it. There's a list of persons. There's an overview of time for those particular persons. There's a list of concepts. These were derived using machine learning in cooperation with our colleagues from Amsterdam, especially the group of Marcel Borring. Here's a set of images that are representative for the current state and the current selection. You can select one person and try to find someone who is similar. Yeah? So, given a selection of the pictures he made, the background shows the overall activity pattern, the yellow one shows the activity of this particular person, and next you can look at what concepts he was interested in, and also what other people had a similar interest. And here we had to work hard to find subtle coding to show when similarities in concepts and space occurred. The background of this work was using visualization for forensic purposes. Suppose that you get hold of hard disks or cell phones of a number of people and you want to see what the interactions are. It could be interesting to construct, for instance, criminal networks. Testing things in practice is a challenge. The police was very interested, and Paul was allowed to put his software on their machines, and then he was sent home, and they used their software without us knowing what they exactly did. But in the end they gave positive feedback. Well, visualization purpose, you really want to see people activate with your software, but okay, here it was more difficult. Example from Cinescope, where you can integrate machine learning with visualization. The case here was to cooperate with the Rijksmuseum from Oudheden, Museum of Antiquities, and the challenge was to visualize their collection and enable people to browse and navigate and look around, both experts and the lay audience. This is a typical item, little statue showing a goddess. There's some description about it. There's information about things like the material, the size, when it was made, where it was found. So, there's data. It's not real big data. There are 57,000 items, but definitely it's quite messy data. You have image data, you have text data, you have geographic data, there's temporal data. Now, how to make sense of that? First, they extracted geocodes from the textual descriptions and enabled a visualization on a map. Next, they used their word wall technique to visualize text. I begged them already many times to publish about it, because I think it's a very, very elegant and cool idea, very simple. If you make a selection, you can apply statistics, machine learning on it to find out what's special about this selection, what words do occur more often. And also vice versa, you can look at, in the elements that are not selected, what words are used there. Well, here you get information about this statue, it's female, it's old, it's a goddess, and also some other words. Finally, there are the images. Now, suppose that you're looking for identical objects, then you could make a guess that also the images probably will look the same. To visualize that, they used a kind of TSNE approach. Each little dot represents one image, and images that are similar are put together. Now, let's see this in action. The screen is subdivided into different sub-windows. Here, for instance, you see the images. This is the word wall for the metadata and word wall for the description. You can select areas, like for instance here, area in Friesland is selected. You can check what was found over there. Next, we select, for instance, one object, pot. Here you find it back in the TSNE. And then you get a lot of other pots. And also on the map you see that they are distributed over the country. Egypt was not selected, but other words like potje, pot, and all kinds of different pots are selected. Now, let's switch to Egypt. The geotagging is not really perfect here. Egypt is reduced to 1 point. But the museum does have a lot of items from Egypt. You can drill down on that selection and find out what's special about it. You see a collection of images, in this case points. These are seals shown as scarabæi. Okay, and by doing this you can browse to whatever you're interested in. The power of the software is that this is a flexible environment and you can configure the interfaces at will. So many of my PhD students still struggling with customizing, programming those interfaces rather than composing them. And they use their approach for many different types of applications, like financial services, insurance cases, for critical infrastructure, security, etc. Okay, back to the overall view. Without losing information is an important ingredient, and you should always ask, should we trust the results? This is a very important question, and to emphasize that I have to tell you first a personal story. About a year ago, I got a letter. It was a letter nobody wants to receive. Everybody hates it. This is the letter. People from the Netherlands probably recognize it. The word beschikking here is very scary and frightening. It comes from something called the Centraal Justitieel Incassobureau, or the Central Judicial Collection Agency, which collects fines. Yeah? For instance, if you made an error in the traffic. Well, the core of the letter says this: you didn't stop for a red light and you have to pay 239 euros. Okay. The date was given, the location, and there the first funny thing started. Location was in Alkmaar. I was born in Alkmaar, I know this place. But on that particular day I was just working in Eindhoven, I was not in Alkmaar. So I asked my wife, and she confessed. She said, yes, I remember that day I was moving my parents from Egmond to Alkmaar, and I was driving behind the van that had the stuff of my parents, and the van went through the orange light, and yeah, I thought I could make it, but okay, I failed. Okay, well, I started out to pay the fine, but on the backside of the letter there was a message. If you're curious, you can have a look at the picture. And then I was really shocked. And there were two pictures. This was the first one. This was the second one. It shows a lot of very interesting things. It shows that this agency is very good in detecting number plates. This is our car. I cannot say else. It also shows that my wife was lying to me. Because you see the van of the moving company, and she was driving in front of it. She was not driving behind it. I asked my wife again, and she said, yeah, I remember the van was not really sure where it was, so I was driving in front of him to guide him. Yeah? Pliability of the human brain, of at least my wife, it's wonderful. There's also another interesting detail. Light's green, it's not red. A week later I got a second letter. You don't have to pay. Sorry if this caused some disturbances. Also found out that this incident made it to the Dutch news. Here you see the device that caused the problem. There was a technician that has flipped two wires. As a result, everybody went through green got the fire. And about 1,300 people got such a fire. You see an example. It's not my wife. Okay, interesting story. What can we learn from this? We can learn that automation is evil. If you let a stupid computer do things, things go wrong. And it's important to have a human decision maker in the loop. Okay, now, who volunteers? Do you want to be that human that's checking out those pictures? Yes, red light, yes, red light, yes, red light. Well, maybe in this particular case, it seems like automation is a good idea. Now and then some incident happens. Well, actually, I think that this case is a wonderful example of transparency. Yeah? Let's reconstruct what happens. You have the authorities, they make a decision on you, you have to pay a fine. You give a reason for that. You didn't stop for the red light. And also, they provide you with evidence, a photo. As a subject, you can have a look at the evidence and reasoning and draw your own conclusions about it. Another example that the system works is that, okay, this was picked up by the news and they signaled it, and I'm sure that the engineers that work on those devices are instructed more carefully to do a good job. And if the consequences would have been bigger, then I'm sure that questions would have been asked in Parliament and would have a lot of discussion. There's these days a strong tendency to make decisions automatically in all different kinds of aspects of your life. Well, so we are moving to a different world, and this is an important question. Should we let the computer decide? Do we trust what's going on? Some people are very scared, very frightened. If you want to also be scared and frightened, read this book, Weapons of Mass Destructions of Casey O'Neill. How big data increases inequality and threatens democracy. There are quite some horror stories in our book how things go very wrong. Most of them are US based, and okay, there's some relation, and we still hope that in the Netherlands and in Europe we have better protection, like for instance the GDPR, but it's important to be aware of this. So you can also look at it from a more positive view and see it as a technical challenge. How can we get transparency? Yeah? How can we present evidence, reasoning in such a way that everybody involved can understand what's going on, validate the results, make judgments? This topic is currently getting a lot of traction in the Netherlands and also elsewhere. I'm involved in a consortium called the Responsible Data Science, focus on fact, fairness, accuracy, confidentiality and transparency. And obviously for transparency there's an important role for visualization people. Also I'm involved in the Eurographics Academy of Data Science, cooperation between Tilburg University and Eindhoven University, with a new campus in Den Bosch, where I'm part of a team that focuses on interaction between data and humans. The puzzle is complex. Partially it depends on what kind of model you use. Rules are easy to understand and to judge. Logistic regression, okay, still understandable. But here we have also deep learning networks. I see that these days in graphics they are also very popular. They seem to be taking over the world. Let's be careful. Type of model is just one parameter. Another very important one is the size of the model. This is something I learned from Fritz Post. You have qualitative complexity in the structure, but also, and you should never underestimate that, you have quantitative complexity. If things get bigger, they're harder to understand, to represent, and to check out what's going on. Now, who's at stake? You have the subject decided on, the decision maker, you have the data scientist. Data scientist makes a model. That model is used for cases. Cases are labeled. Decision maker makes a decision. All these different people in the loop have different questions. As a subject, I want to know if I understand and agree with the decision. As a decision maker, you want to check if the decision provided by the model matches with common sense and domain knowledge. And as a data scientist, you want to make sure that your model is correct. Yeah? I think that in many cases, people don't have the intention to do evil, but it could very well be that if you let models be generated automatically, stupidity creeps in, and that, for instance, you make mistakes about what you use as a proxy, that you confuse correlation and causation, etc. So, therefore, also those people should have the possibility to check out the models. It gives you many different challenges. The needs of the stakeholders varies. Presentation is a puzzle. Interaction is a challenge. My dream here is that you can have a very smooth pattern, like you see the overall decision being made for one particular subject, that you can smoothly navigate through the model and get a big picture and do all kinds of checks if the decision was right or not. I just have got a grant proposal awarded for 3 PhD students, one on the data mining side, one on the visual analytics side, the third one on evaluation, cognitive psychology. So if someone is interested or has grad students that want to work on it, keep in touch. I'll show you quickly a number of examples of things we have done in the past. Stefan Elsen has worked on visualization of decision trees, part of his master's thesis. The pattern here is that here in the center you see the decision tree. These are the classes, these are histograms, these are the splitting points, and you see that different classes move to different next levels, and here recursively it continues. A lot of support is offered when you construct a decision tree. For instance, given a certain node like this one, the suggestion is offered what's the best way to split it, depending on the variable. Confusion matrices, the raw data, there are options to automatically construct a decision tree so that you can later on manually tune it. Also, you see here a lot of buttons that trigger different layout algorithms. That enables you to make interesting pictures like this, showing a decision tree for tumor location. The message here is that on the highest level, first there's a split made on the sex. This is another example showing 4 different types of cars. Here you see that it seems to be hard to split up the Saab and the Opel. Well, it's much easier to split up the bus and the van. This works out quite well. We heavily lean here on that we are using a decision tree, and one of the big advantages of decision trees is that they do lend themselves for interpretation and visualization. You can quickly explain what the principle is. However, in practice, people these days, when they're using an approach like this, they typically use random forest collections of decision trees. And, well, we don't know yet how to do that. Another case, sort of the opposite extreme. Here we show a strong simplification of a very complex model. Show the results for one particular case. This was a cooperation between University of Nijmegen and the customer was the company Thales. Now, high level, this was the pattern. Suppose that you have a number of observations, put them in a reasoner, and the reasoner gives you some conclusion, like there's 75% chance that this object is dangerous. In this particular case, the data was all about vessels, about ships. It was AIS data, sort of GPS data, but also radar data, web data, data in databases, even Twitter messages. All this data was put in a probabilistic first order logic inference engine. Think about a Bayesian network on steroids, a 300 by 300 matrix completely filled, showing all the connections between different components. And a conclusion was sent to the Coast Guard. Now this Coast Guard has to make decisions like, should I send a ship or a helicopter to check out this dangerous vehicle or not, dangerous vessel or not? Well, that's quite a costly decision. So just this information, there is a chance that there's something going on, is not enough. He wants to have an answer why. So the machine learning guy, my student, Roland Schepens, worked closely together. Stefan Michels was able to get a simplified version of his model. Roland Schepens worked hard on presenting it. Here you see what he came up with. The conclusion here is that there's an increased chance of reckless behavior because the vessel is smuggling. Why do we think it's smuggling? Well, it's hiding its identity because it's probably messing around with this AIS idea. And that conclusion is drawn from the evidence that's shown here. Each column here represents a source of evidence. The rows represent different aspects. And one of the nice little details here was the coloring used. He used the convention that if sources agree, they are assigned the same color. So here you see strongly there are two sources that fully agree. Here is two databases and there's a lot of disagreement. For instance, on the name of the particular vessel, some sources think the name is the Black Pearl, the other one think it's the Flying Dutchman. Okay. We tried it out on experts, it also went on fairs, and it was amazing how well this worked. Yeah? Very quickly the experts on vessel traffic started to explain us what was going on in particular situations. They had no problem to understand what was going on. The final case, very recent, about insurance fraud detection. Another case where we strongly simplified the model for one case. The data set 40,000 insurance policies, 50 attributes, and only 129 confirmed cases. The model here was very complex. Actually, it was a collection of random forest models. After some time, halfway this project, my student made a picture using T&E, and it was really scary. The red dots represent fraud cases, and you see that they are really all over the place. Still, he worked hard to try to get some signal, for instance, what particular features are important. We hoped that this would be effective. You show the result for one particular case, then you wiggle the value of an attribute and you see what happens with the score. Well, the signal we got was not that strong, it was not really effective. We got a lot of success with this approach. He distilled a highly simplified model consisting of just a handful of rules to say if something is fraud or not for one particular case. And the experts were totally excited about it. It gave them a lot of insight. Well, on our side, I had very, very strong doubts because this is just one set of rules you could use to explain this particular case. Many other sets of rules could also be very applicable. So for me, it was sort of scary how quickly experts believed that what came out of the computer made total sense. So we're still working on it and work on progress. Time to wrap up. I told you something about information visualization, about visual analytics. I hope to convince you that we, as a visualization and also as a graphics community, have almost the obligation to work on this topic. Transparency in automated decision is a very important topic. Also, it's very challenging, and I'm not sure yet how to solve a lot of things. And that brings me to my main take-home message for today. Next time, stop for a red light, because in Holland there's a 239 fine for that. Thank you.
Thank you very much, Jarke, for this fantastic talk. We have time for questions from the audience. If somebody has a question, please step up to the student volunteers who are carrying around the mics. Maybe to kick it off, let me ask you a meta question, because you told a story about the red light and there were two wires split that basically led to a catastrophe in that sense. verifying machines, there is something like provability, right? You can run a lot of tests, you can even sometimes, let's say, really theoretically prove that something is working. For human beings, it is much harder. So is there actually a place for humans in the decision process in the future?
I have discussions on this topic with my colleagues from psychology, and they continuously ask me the question, why do you want to have the human in the loop? Don't you know that there's many problems, a lot of bias, a lot of wrong decisions? Well, I'm increasingly becoming aware of that. I think in the end of the day, the human has to be in the loop to decide on values. I don't want to let the machine decide on that. Also, common sense. The human has an important role, but also we should be very much aware of limitations, not only the strengths of humans, and take care that we give a message in such a way that we address this. There's sort of ambiguity in this place, in the field. And also in your work you have many examples how you can use the strengths and also limitations of perception to get wonderful effects. And I think this arena where also you have to be very careful about it. And so I don't, of course, it's important that you, if you can prove things, you certainly should do it, and if you don't have faster algorithms, etc., you can apply a lot of techniques, but the real challenges are more at the human side.
Yeah. Any questions now from the audience? Yes, please, over here. Albert Hauser, would you bring the mic over?
Okay, thank you very much, Jarke, for this amazing talk. You have previously taught us about the value of visualization and how to compute it, and we all know that interaction, while it is essential for gaining insight, it's very costly. It takes the time of the user, which is very expensive usually. So what is a good approach to optimizing this cost-value relationship?
Well, most important is try to understand what your customers need and want. It's almost the very first thing I tell students when they start a project. Make a list of questions that your users have. And if the questions are very specific, like I want to compare this city against this city for this and this kind of things. You know in advance that this city will vary among the different users. That's a typical example where, okay, this interaction is important, and it's better than showing a picture where you show all aspects of all cities in one big plot, so that you have to reconstruct it. So that's also simply the scale of the data. In contrast to 20, 30 years ago, I'm not trying to show everything in one screenshot anymore. On the other hand, if you can, you should try to do it, but as you also know, you very quickly hit the boundaries. And often it's a nice challenging puzzle to try to get as much information on one screen as possible. If I watch the Dutch news, for instance, they seem to be obsessed that it's always wrong to show more than 3 numbers simultaneously. Okay, that's an extreme I don't want to reach. People can handle more things than can. Maybe they need some education so that they can understand things like scatter plots, things like that, and then you can show more data without too much interaction, and in the end that's more efficient. But in the end there are no solid rules or guidelines. More and more I'm convinced that developing effective visualization is a matter of design. You have to look at your situation, make compromises, select things, evaluate things, and come up with some solutions. Well, it's a task for our community to provides solid guidelines and golden laws, but okay, we should tell people what are good ideas and what they should try to do. But it's very hard to do it automatically or fit it into one algorithm.
Thank you very much for this answer. For the sake of time, we will have to cut the session at this point. But Jarke will be around during the lunch, and so don't hesitate to go up and talk to him. Additionally, during this lunch session, there will also be the poster event. So take a look at those as well. And with this, I thank you again for your exciting talk. Thank you very much. And there's my
It's a historic moment.
Are you happy with
That's trouble.
Yeah, it's okay. It could be better, but you know, it's okay. Not very high. Low budget. Low budget. Yeah. I still remember you gave a keynote at Synviz. I think it was 2009. Was that 2009? Do you remember?
It was the latest,
the last Synviz. Yeah.
Not to me, maybe it's right.
That's why I was
I still remember your talk in Viz 2003, the Flow Viz 1, and of course the capstone in Atlanta, right? It's in Atlanta. That was a good one. That was a good one. I still remember one of the slides, which is very
I feel I have to go there.
the slide where you were talking about working with domain experts.
Yeah.
So you had this conversation and you showed a bunch of equations, and then 6 months later, the domain expert disappears. That was so funny. So funny.
I have a new joke in my talk.
Okay.
So the joke you don't remember.
Okay, but you are still also.
Alright, I'm going to stop talking so you can concentrate on this.
Yeah, started in front.